In this video, we will continue solving systems of equations with substitution. However, we will find to use substitution, we may have to first isolate a lone variable to allow us to make a substitution. If there are several lone variables, we may pick whichever one we want to pick. For example, in this problem, we notice that there is a lone variable, or a variable who has no coefficient or number in front. This is the one we will attempt to isolate. We can get the x alone quickly by adding 2y to both sides. When we've done this, we see that x is equal to negative 13 plus 2y. We now have that x equals equation we need to make a substitution. X is equal to this expression, and we can replace the x in the other equation with that expression. 6x becomes 6 times negative 13 plus 2y plus 4y equals negative 14. We can solve by distributing, giving us negative 78 plus 12y plus 4y equals negative 14. Combining like terms, we get negative 78 plus 16y equals negative 14. Adding 78 to both sides gives us 16y equals 64. Finally, get y alone by dividing both sides by 16, and we find y is equal to 4. Again, we still must find x, and we find that by taking our value for y and plugging it into the x equals equation to find what x equals. X is equal to negative 13 plus 2y. We just found out y is 4. Multiplying, we find x is equal to negative 13 plus 8, or x is equal to negative 5. As an ordered pair, x comma y, negative 5 comma 4 is the solution to our system of equations. Let's try another example where we must first isolate a variable before we're allowed to make our substitution. Here, we have a lone variable, y. It is not isolated because it has the negative 5x. We can add 5x to both sides to get that variable alone. We now know y is equal to negative 17 plus 5x. If y is equal to this expression, it must also be equal to that expression in the other equation. And this is where we make our substitution. 7x plus 8y, our y is negative 17 plus 5x equals 5. And again, we solve this equation by first distributing the 8. 7x minus 136 plus 40x equals 5. Combining like terms, we find 47x minus 136 equals 5. Adding 136 to both sides, we find 47x is equal to 141. Dividing both sides by 47, to isolate the x, which is equal to 3. Again, we still need to know what y is, so we go back to that y equals equation and replace our x with that 3. Y is equal to negative 7 plus 5x, or 5 times 3. Multiplying, we find y is negative 17 plus 15, or y is negative 2. As an ordered pair, x comma y, 3 comma negative 2, is the solution to our system of equations. By isolating our variable and substituting, we can solve our system.